Hi, my name is Carol, and in this section we're going to talk about the best practices on how to collect and prepare our samples for Western blotting. On the previous science video, Darren went into detail about the science behind how should I be collecting my samples, how I should be extracting my proteins, how I should estimate my protein concentration, as well as how I can store them and then prepare them to run my Western blot gel. What is important for us here is to remember that our Western blot data can only be as good as the quality of our samples. So we should actually put a lot of effort into preparing our samples so we can start this whole protocol with the best foot forward. Since our Western blot data can only be as good as the quality of our samples, we really want to make sure that we have great quality samples to start with. Now, in a perfect world, we would only use fresh samples for our Western blotting. In real life, it may not be that easy. We may have a lot of samples or even different time points to deal with. Now, despite of if you're going to choose to use your samples fresh or not, as soon as the samples are collected, you should maintain them at 4 degrees. You can use ice to help you with that. Maintaining your samples at a cold temperature is going to help stabilize the proteins as well as reduce enzymatic activities. Remember that as soon as cells are disrupted, several enzymes, including proteases, will be released, and their activity can really affect the quality of your data. Therefore, it may be a good idea to add protease inhibitors as soon as your samples are collected. However, keep in mind that if you have to freeze those samples, protease inhibitors are not stable at minus 80 degrees. So when you're ready to thaw those samples and continue your protocol, you're going to have to add fresh protease inhibitors. To ensure that you have great samples to work with, it is recommended that as soon as you harvest those samples, you proceed with the protein extraction. At that point, you're ready to perform your protein assay. Then you can decide if you're going to move on with your Western blot using those fresh samples or if you're going to have to freeze them to use them at a later point. Now, if you've ever been frustrated trying to reproduce Western blot data using frozen samples, and I know I have more than once, this right here could be a problem. Different proteins have different stability levels, meaning that they can be more or less susceptible to protein degradation, a process that is exacerbated by freeze-thaw cycles. So whenever possible, we want to avoid freezing our samples, but when that's not possible, we want to at least reduce the number of freeze-thaw cycles. And a good way to do that is to prepare small aliquots of our samples so that we only have to freeze them once and then thaw them once when we're ready to perform our Western blotting. When we freeze our samples, one of the main issues we run into is the formation of ice crystals that affect the ice-liquid interfacial tension as well as the salt concentration of our samples. Those things affect the protein stability and can therefore lead to protein degradation, which is something we definitely want to avoid. There's a few little tricks that we can use to try and avoid the formation of ice crystals. One of them is to add glycerol to our samples. However, how much glycerol you're going to have to add can vary depending on your sample type, your sample buffer, and even your targets of interest. It's going to be anything between 0 and 50%, and you're going to have to empirically determine that. Another cool trick is to perform flash freezing, meaning that instead of simply placing your samples at the minus 80, you're going to submerge them in liquid nitrogen. That way, that freezing process is going to happen as fast as possible. Similarly, when you're ready to perform your Western blot and you're going to thaw those samples, you're going to perform a flash thawing, meaning you're going to thaw them as fast as possible. Those three things, adding glycerol, performing a flash freezing, and performing a flash thawing, are going to help reduce the formation of those ice crystals. Now, remember that the particular conditions that are going to be optimal for your particular sample to be frozen is going to depend on your sample. So you're going to have to empirically try a couple different conditions to figure out which one works best for you. Now, if you're working with tissue that is delivered to you frozen, you're obviously not going to be able to perform the protein extraction before the tissue is frozen. In those cases, you may want to take advantage of commercially available buffers that are designed to help maintain protein stability. They can really help maintain the quality of your samples for your downstream Western blotting. Now, since we're talking about freezing our samples, let's remember once more that protease inhibitor as well as reducing agents and sample buffer are not stable at -80. So you definitely want to add protease inhibitor when you're harvesting your sample, but if you freeze it, you're going to have to add it again when you thaw it and you're ready to perform your Western blot. It's probably a good idea to wait until you're preparing your samples to load the gel for you to add the reducing agent and the sample buffer. The presence of contaminants such as DNA, RNA, lipids, and even solvents on your sample can really affect the quality of your protein sample. That can lead to problems with the separation and resolution of your SDS page, leading to artifacts such as smearing and band warping, which is definitely something that we want to avoid so that we can properly quantify our Western blots. To help you with that task, make sure you closely follow your protein extraction protocol. If your protein extraction protocol includes a sonication step, the sonication is going to shear the DNA into small fragments that will not interfere on your Western blot protocol. However, if your extraction protocol does not include a sonication step, you can solve that problem by adding DNase 1 to your extraction buffer, getting rid of those oligos that could affect the quality of your sample and lead you to having those artifacts on your Western blotting. Now let's talk about a few more tips on how to get your sample ready to load on that gel.